Hello, how are you doing today? Today we're going to talk about probability. It's chapter 5 in your statistics textbook. We're going to talk about the addition rules, the multiplication rules, and a little bit of the counting rules in probability. So first of all, I'd like to show you your handout, which you should have printed out ahead of time. This is the Chapter 5 handout that we have posted on Blackboard that you should print out, follow along with this, and go through my PowerPoint presentations. I think the definitions you can follow along, but I'd like to concentrate on mutually exclusive, the definition. And the best way to discuss that is with the addition rule, mutually exclusive and not mutually exclusive. On the PowerPoint presentations, I show you Venn diagrams. For example, if I ask you what is the probability of getting a king or a queen, you're picking one card, the probability of a king or a queen. If I do Venn diagrams, there's 4 kings and 4 queens. Mutually exclusive. You would just add those probabilities. There's 4 kings in a standard deck. When I discuss a deck of cards, we'll always discuss a standard deck of cards. And 4 queens. Add these, the probability is 8/52. Mutually exclusive. Not mutually exclusive would be the probability of a king or the probability of a red card. Again, we have 4 kings. We have a king of diamonds and a king of hearts. So when we say the probability of a red card, we need to include those. How many red cards in a deck? 26. Half the deck is red, half is black. So there's 26 red cards. So the probability of a king is 4/52. And when we said 4/52, we included the diamond and the heart. The probability of getting a red card is 26/52. And we included the king of diamonds and the king of heart again. So therefore, since we included it 2 times, we have to subtract out. Because we can only include 1 king of diamonds and 1 king of heart. So therefore, the probability is 28/52. 4 plus 26 minus 2 is 28. Now, I'm doing this in fractions, okay? And you know how to turn it into decimal, the numerator divided by the denominator. I want to remind you, your test will be in decimals and your final exam will be in decimals. The other thing with this chapter and chapter 6, it will be all multiple choice. So I just want to give you a warning about that. Multiplication rule. Multiplication rule is 2 events. For example, you need to understand the definition of independent. The probability, let's say, of driving a red car and the probability of passing statistics. Well, I gave you the probability of driving a red car is 5%. The probability of passing statistics, let's say it's 94%. 2 events happening. You multiply these. And if you multiply 0.05 times 0.94, you always put it in decimal form, you get 0.047. If changing that into a percent is 4.7% chance of I randomly selecting someone and they're driving a red car and they're going to pass statistics, independent. Okay. Not independent. This can be best illustrated with perhaps a bag of marbles or cards. not independent. I like to tell people not independent means not replacement. You might want to write that down. For example, I have a bag of marbles, 5 red, 2 blue, 3 green. I want to select a red one on the first pick. I put the red one in my pocket. I don't replace it. And I want to select a blue one on the second. So the probability of a red, we should always total these, which is 10. Probability of a red is 5 over 10. The probability of then getting a blue, we still have 2 blue, but how many marbles are left in the bag? 9, because that red one is in my pocket. And this is all called conditional. You have to assume that the first pick is the first event did happen. We did get a red one. When you multiply these out, 10 times over 90 and 0.1111 or 11.11%. Now I'd like to show you an example that kind of combines both of them. In this example, remember, I had to choose a red one first and I had to choose a blue one second. Now I am going to get either a red or a blue. I don't care about order. So that probability, I can get the probability of getting a red first and then a blue. However, I need to add it to the probability of getting a blue and then a red. So the probability again of getting a red is 5 over 10 times 2 over 9. Oops, I have to put the probability of getting a blue and then the probability of red. Sorry about that. Here we have the probability of getting the red first and the blue, but we also could get the blue first and the red in this one. So the probability of a blue is 2 over 10. Probability of a red is 5, and this is without replacement. We're talking not independent. They're dependent on each other. So we have 0.111 plus 0.1111, and we have 22.22%. Okay, to review that. Again, this one I had to get a red one, and then I had to get a blue one. That was how I wanted, that's how I was going to win. In this example, both of these examples are independent. However, on this example, I said I could either get the red first or the blue first, so I had to add those two probabilities. Okay. Another important point in probability that I'd like to go over, and this might be is arranging letters. For example, if I have 3 letters A, B, and C, and this is part of the counting rule, and I want to know how many different ways I can arrange them. Well, if I have the 3 letters, I arrange them, I can do it by hand. However, if I give you many letters, it might not be that easy. Or if I give you people. If every letter is different, it's very easy. You just say 3 factorial. Remember that this exclamation point from high school is factorial. It's located on your calculator. Remember, on the TI-30, you just hit the probability button. On the graphing calculators, the 83 and the 84, you have to hit the math button, go over to the probability button, and then option 4. Those instructions are on Blackboard under reference if you don't know. You can also email me if you have a concern. So back to arrangements. 3 letters, all of them are different. 3 factorial. 3 factorial means 3 times 2 times 1, 6. There are 6 different ways to arrange the letters. Great. How about if they're repeated letters? And this is the example in my PowerPoint, E-E-L. Well, here there's only 3 different ways to arrange the letters. We still put 3 factorial. However, this is the total number of letters. But we divided by how many repeated letters. Here we have 2 E's. We divide it by 2 factorial. And this is repeated letters. So 3 factorial divided by 2 factorial is 3 different ways to arrange the letters. Great. So here is one more example. I have the letters A, B, A, B. There are 5 letters. Whoops. 1, 2, 3, 4, 5 letters. So I have 5 factorial in the numerator. I have 3 A's, so I divide it by 3 factorial. And I have 2 B's, so I divide it by 2 factorial. When you do this, make sure when you put it on in your calculator, you put parentheses. When you do this, there's 10 different ways to arrange that. You will see an example like this again. Whether it's on the test or the final exam, this is an important concept. Okay? Another counting concept I'd like to go over today is, and you have some examples on your PowerPoint. Let's talk about the Albanian alphabet. I had a couple of students from Albania last year, a couple years ago, and they insisted that when I ask a question like this, they use the Albanian alphabet, and I thought it was a good idea. First of all, you need to know the Albanian alphabet has 36 letters, not 26 like our alphabet. It is true, airport codes use a 3-letter code. Okay? In fact, we're running out of airport codes, and they're devising a new system. I want to know how many possible combinations of letters are possible if we use the Albanian alphabet and there's no repeated letters. So, here's a little hint here. There's 3 letters. The first one has 36 different letters to choose from. The second letter has only 35 because we used one in the 36. And the third one now only has 34 different possible letters to choose from. If we multiply these, we have 42,840 different ways we can take the Albanian alphabet, choosing only 3 letters and no repeated letters. And we can make 42,840 different combinations of the Albanian alphabet. Okay? If you could repeat letters, if we could have repeated letters, we could have done 36, 36, 36. And you can do that on your calculator. Okay. So the last concept in Chapter 5 that I'd like to go over is I'd like to discuss permutations or combinations. Find this and this on your calculator. Once again, on the TI-30, it's located under your probability, PRB button. In your TI-83 or 84, you do have to go to math and probability again. Permutation, order matters. For example, ranking in class. Your ranking is first, second, or third. If I have 3 people in class and ranking orders, or something like scholarship. Let's say there's 3 people. There's Joe, Sue, and Tom. Okay? The first person's going to win a $1,000 scholarship, $100, and the last one's going to win a $2 scholarship. So guess what? Ranking does make a big difference, right, if you're getting those scholarships. Okay? This permutation button, this is sample size. I have 3 people, and I'm going to select all 3. Okay? Order matters. The combination key. Combination key, order does not matter. Let's say I have those 3 people, okay? And I'm going to form a committee of 2 people. Well, if I select Joe and Sue, it is the same committee as if I choose Sue and Joe. So I don't count that one. I do count Joe and Tom, but I do not count Tom and Joe. Okay? And the last one would be Sue and Tom, but I would not count Tom and Sue because they're the same people. So there are 3 ways if given 3 people and I want a committee of 2. How would we write this? We would write there are 3 people, C, and I'm selecting 2. Okay? If you do this on your calculator, you should get 3. Okay? I tell people, remember, when you're reading a word problem, if it says something like committee or order does not matter, it's a combination. Permutation, a good example I like to tell students is here at Hudson Valley. Does it matter if, say, if you have 4 classes, BTC, daycare, Bran, and Williams? Does it matter if you go to BTC, daycare, Brand, and Williams, or BTC, Brand, daycare, and Williams? Yes, it does matter. It saves you about a half an hour of walking. Okay? So if you're doing routes, for example, UPS and Federal Express, they have computer programs that minimize the routes because order is important. Okay? Just a little fun fact before I let you go today. Federal Express, their programs that they have their drivers do, it's very interesting because their programs say they only want their drivers to take right-hand turns. And you're like, what? So they come out, they take a right-hand turn, they take a right-hand turn, they take a right-hand turn. They might take only right-hand turns until they go home. And they also minimize their routes because order is important. But they also put right-hand turns. What happens if you only take right-hand turns? First of all, you can always go right, usually go right on red. Saves time. Second of all, if you have to take left turns, you have to wait for the oncoming traffic. Again, saving time. The other thing is if you take a left-hand turn, there's oncoming traffic, and you can also increase your chances of an accident. So they reduce their accidents by programming only right-hand turns. By doing a simple calculation or a simple route of only taking right-hand turns, they save each driver's hours of time a week, therefore reducing their minimum cost. So I think that's enough for this video on chapter 5. I probably will, thank you. I probably will do a little video on Chapter 6, which is binomials. And again, if you have any questions, you are welcome to email me. You are welcome to schedule. You can come and see me during my office hours. Even if this is a hybrid class, please come and see me during my office hours or contact me. So good luck.